Well, thanks everyone for showing up. My name is Bert Belder. I came here from Amsterdam to do a talk on the future of Node.js. But since there's no MC here, let me introduce myself a little bit. I've been working on Node.js since like for 4 years or so, like 4.5. Started in 2010. I was one of the authors of libuv, which is an underlying library that abstracts away differences between platforms. We built the entire Node.js since version 0.6 on top of that. And since then, I've been involved. For the last year, actually, I was a little bit more behind the scenes, so you won't see many code commits, but I'm still very much involved with the core effort. And 2 years ago, actually, I founded, together with a couple other people, the company StrongLoop, which tries to commercialize Node.js, especially for big enterprises. And so if you are a hobbyist or a small shop, you can enjoy all our efforts and all our investment in it. I want to show you this picture. Anyone recognizes this? Yay! Well, I see only a few hands. This is June 2. So I've been programming since I was a little kid. I think I started when I was 8. But I'm actually not a very good programmer, and the reason is this, because like about the same year this game came out, and it's the mother or whatever. It's one of the first real-time strategy games in the world, and I enjoyed it very much. So the reason I'm showing you this picture, well, there's many reasons, but one of them is when I started working on Node.js, me and Ryan Dahl, we used to make this joke. You know, we are striving for world domination with Node.js, and I always thought of this, like, you know, we are the troopers here. We are trying to dominate, you know, a planet with a programming language. Now, the even more funny thing is, like, this guy, it's called in the game, it's called your mantat. Now, when I founded StrongLoop, one of my co-founders is Isaac Roth. And I thought I recognized him, but for a long time I didn't know who he reminded me of. But now, look who he is, right? I've known this guy all my life. All right, and this is nowadays actually he is my my mantat. He's a Java guy actually, or used to be a Java guy, and of course that creates tension. And I think that's a really good thing. I think if you work on a programming language or a platform, having someone that has a very different perspective than yourself is really helpful. Now, I want to talk a little bit about what Node.js is, because chances are, if you are here, you might have learned about it because the AngularJS README told you to install it. Or, you know, you heard about how great Gulp was and that it has won some prize, and you think that is what it is for. Well, actually, when we started Node.js, we wanted to build a better web server. I of course, didn't invent it. There was another guy, Ryan Dahl, as I said. And he came from Ruby, and he figured that evented programming is really nice, but Ruby was really slow, and JavaScript fit better. But nowadays, of course, people use it for all kinds of things. There might be even people here that are for the IoT conference, and they think Node.js will, you know, run their UFO, or it will control an army of drones that will, for them, conquer the world. It's not happening yet, but maybe. But so my perspective on this is that Node.js can be many things. But I wonder often, like, why is it so successful? And I think these were the two reasons. I think this is not news for you. It combined two very interesting ingredients, which is taking the language of the web to the server and making concurrency manageable. Making concurrency manageable is something that nowadays we take for granted. It has been adopted by many other languages. You have Java and I/O. I think there's more. There's Go, for example, that tries to take asynchronous to the next level. But when we just started, they were so thrilled because suddenly they could write a chat server. I think when you went on Hacker News on 2011, every day there would be a post where someone would, you know, yeah, I wrote another chat server. And of course, this stuff really gets old. But at the time, it was really empowering for people. And managing concurrency also means performance, and the situation where suddenly your server could have like more than 100 open connections at the same time. This is, by the way, still an issue. So like I work at StrongLoop, and what we do is we build API servers. That's one of our products for big companies. And this was a test by a big US bank, which I cannot name, or the results of a test. They did a couple of weeks ago. And what they found is that when they used Node.js as an API gateway for like a slow backend, it would outperform Java. Java is like the blue line. It is, oh, you have the cursor is not visible. Like when they have a slow backend, which means that the concurrency goes up, right? Like Node.js would only drop off a little bit in performance, and Java would go down very fast. Still, like in 2014, you would think this has all been solved. But if we think about the future, of course, we have to think about not only what we are, but what we want to be. Especially if you consider that Node.js is now 5 years old. Like, in software years, maybe I try to compare software years with dog years. We would be like late 30s, I think, which means it's time for our midlife crisis. And now before Node takes off in a sports car, let's think about what we want to be. Well, let me remove this. The car might not like to be objectified. Or maybe to go back to do like select your next conquest. What do we want? Where do we want to go next? Now, before we carry on, like this is my perspective. Node.js is a community project. I do not pull the strings, certainly not on my own. What I say may not become reality, but the reality is, though, that we take our user input and what we learn from like users very seriously. And so if you are welcome to disagree with me and like find me after the talk. Please don't beat me up. Also not with Lisp, because I do not speak. And tell me that I was totally wrong. Like, please disagree with you. So select your next conquest. I've picked 3 that I want to discuss. 3 areas to conquer, which is, one is Go. And Go is, of course, weird to conquer because it's very new and it's actually much smaller than Node.js, but it has interesting ideas, and that's something that we can learn something from that. Something else that we still have to beat, unfortunately, because we have been trying for years, is Nginx, but we get closer every like day or week, whatever. I want to discuss a little bit about how, and that's more of a technical thing, how we can become a better web server. And finally, we want to be a better platform. It's nice to have a mentor that's a Java guy, because he has all these insights like this. We have been doing this for years in the Java world. Like, why can we not do this in Node.js? Those are valid questions, and we should try to address them. But let's start with Go, or get better at async. Actually, it's not much about Go. Now, this is familiar to you. By the way, this is the only section with a lot of code in slides. And actually, you don't have to read all the code. I will tell you when the code is interesting. Callback hell has been around for years. And for a long time, we, basically as a Node community, put our heads in the sand. And we said, no. If you cannot deal with callback hell, like, if you don't like them, you must be like too dumb to use this stuff. I think the reality has changed. We have become more accepting of the fact that this is actually not so great. And I think the environment has changed because there is sort of light at the end of the tunnel. People, like, there's ES6 generators coming, and it's widely understood that these could help to solve callback hell. I'm not going to explain ES6 generators in detail. There's many other talks in this conference that deal with that. But in this particular case, like this is a prime example of callback hell. Now, what you can see is like sort of the Christmas tree. The indentation gets deeper and deeper, and I'm actually doing the wrong thing here because every time I should be handling an error, I'm just throwing it, and I don't know what happens. Your node process crashes if you do that. So don't do this. But we see the future, right? the code library by TJ Holloway-Chuck. TJ Holloway-Chuck created the Express framework, which is the most popular web framework for Node.js. And he has been running this experiment for, I think, a year now, where he actually tries to like wrap Node APIs in a different way or package them in a different way. So you could use like this yield keyword that is supported or created by ES6 generators to defeat callback hell. And what you will notice is that this code is actually much shorter than the previous slide, right? It's also easier to read. You can understand what's going on. Now, this is really nice. There may be people that are from the C# world or maybe the Lua world here, and they're like, yeah, well, great news. Like we've had this for years. I'm sorry about that. It's true. But maybe I can give you a little bit more perspective, and I will also say this is not the only problem that we have to solve with managing async. Like this is where it all starts. It's not where it ends. And the reason is this. Like this is all, if you are a Node.js user, you know this. Like what went wrong here? Can I see hands? Like anybody knows what went wrong here? Well, you must be magical because I do not know. Like this tells you nothing, right? Like what went wrong here? I don't know. Like I don't actually do. Like someone hung up the connection, but like what were we trying to do? Nobody knows. The stack trace also, like it tells you nothing. It changes every Node version because we change the internals and you see the internals there. Anyhow, the reason that Node cannot tell you more is because Node doesn't know what you're doing. Let me show you this. This is a timeline of Node, but I added an extra dimension. Unfortunately, I cannot point at the slide, so I'll have to describe what I mean. If you think about a Node program, it starts always like with the first tick. So you say node, like app.js, for example, and it executes the code. But then your node doesn't exit because it is an event loop. So if you did anything asynchronous, it will then start dispatching callbacks. And actually, like for the rest of the lifetime of your Node program, all it does is dispatch callbacks. And in this timeline, actually, you can see the callbacks because I made them a little bit brighter, and I put like CB in there. And what you will notice is that if you read the time in that direction, there's like at every vertical like sort of position, there's only one bright thing. Because Node.js is single-threaded, it cannot run multiple, like it cannot execute multiple JavaScript code in parallel. It can do things in parallel, of course. Like those are like the darker bars. Like it starts with saying, with doing set timeout on the first tick, and for a long time it's like, well, set timeout is actually not doing very much. It's like very explicitly doing nothing. But like for a long time it's waiting, and then suddenly the callback comes. And at the first tick, what we also do is like we say accept. And of course you never do this in Node.js because that happens under the hood. That happens in libuv, but you say accept, which means wait for a new connection, wait for some new client from the web, for example, to connect to me, and then give me a callback. Give me a callback when you actually accepted the connection for me. And then in that callback, for example, what we do here is we call read, which means like receive the data that someone sent on that connection. In this case, probably the connection that we just accepted, and we also accept another. And so you get this timeline, but what you can see here is that there might be some relationship between what you're doing. But Node.js has no insight. It doesn't know. So what happens if we get a stack trace like that tells you nothing? It's basically like Node shows you a snapshot. It knows where it is. And it's in a callback that came after a read. That's where the pink line, that it tells you that. Actually, what Node could also tell you, but it doesn't, is that in the meantime, when the exception happened, there was a set timeout going on, but it hadn't completed yet. And there was another read also going on, but it also hadn't completed yet. Node doesn't tell you that, and we could maybe add that. It is not necessarily super interesting. Now, let me show you a little bit more. What if we could draw a line? What if you could tell Node, hey, this is related? Because I can tell, it's a little bit hard to explain maybe, but all these things that are in this waterfall, for example, might be related to one client connecting to your server, you reading some file, processing some data, accessing a database, maybe rendering a template and then sending it back and then saying goodbye, okay, we're done here, right? That is a step that you take in response to someone connecting to your server, but Node doesn't know that you're going to do that. So what if we could actually draw this box? And what if we could nest this? We could add another dimension. So let's say this part would be querying a database. And the querying a database itself is sort of not an atomic operation, but like a group of things that mean something together. Now, if we could do this, what we could tell you is, well, we had an econ reset. And the reason is, well, in this case, we said, it's not related to the last picture, but in this case, we could tell you much more. We could say, well, this was related to this like pink box, which was posting an image to a web server. And that was in another box, which had the bigger concept of storing an image, for example. Like it might be posting the image and also inserting some row in a table, which is together forms a logical operation. Now this is a really important way to think about how we can improve callback manageability in Node in the future. Actually, I've been experimenting with this. It's called zones. And so you can think of the pink box as a zone. This is the syntax. So like there's a library on the internet. I will give you the URL a little bit later, that lets you create a box about things you do. And in this case, we create a zone around reading a file and then uploading it to some web server. That's all. Now, of course, the more critical people in this audience must be like, hey, this looks like promises. That's like old news. And it does look like promises, and it looks purposefully like promises. But the difference here is that promises does not establish structure in your program. In a promise, you would have to tell Node at the end of the zone.create in this case, but that would be new promise or whatever. You would have to return what it depends on. You would have to track manually what you do. We think that it's important to do this implicitly, to tell Node what you want to do, and so Node can do these things for you. By the way, so this is the URL, by the way, if you want to take a look, you can try it out. It's sort of alpha stage, but usable, and as far as I know, it has no bugs in the things it is supposed to do. Now, of course, this is only one case. Maybe more importantly, what you want to do is have more flexibility with asynchronous and synchronous. If you are a grunt user, you might think that Node is actually synchronous because that's how grunt abstracts things for you. Sometimes it has to jump serious hoops to get that done. So last year for Node 0.12, which should be released hopefully in a couple of weeks, I worked on a feature called Exactsync. And Exactsync is something very basic, you would say. Just like Node has write sync, for example, which synchronously writes a file. It has a couple of synchronous APIs, but it had no Exactsync. But Exactsync actually is quite complicated because what Node has to do when it creates a sub-process, or and it calls out to curl or whatever it does, it has to manage a couple of asynchronous things at the same time, but not run its entire event loop. And how we managed to fix this is to create a nested event loop. In a synchronous function call, what we do is we create another event loop. In that event loop, we create a child process. We create a couple of communication pipes and a timer and some buffer manager and a signal handler, if I'm correct. This all runs in a sub loop, and then suddenly, when this all is done, the event loop decides to exit, just like Node would exit if it had no more things to do. Like when there would be no more callbacks, Node would exit, and now in this case, the sub loop would exit. And by that time, we know we can resume the main event loop. Now, it was actually quite difficult to write this because it has to be done all in C or C++. It would be super practical, I think, if you could just do this in JavaScript. If you could just say sync and then put everything what you want to do synchronously there. Maybe quite complicated operations or things, like HTTP request would usually require a couple of back and forth and different asynchronous things going on. And then decide, well, when it's done, do this. Actually, it would not even need a .then and .catch method because it's synchronous. We could even return the result. These are all things that we have to do to manage concurrency even better in Node.js. Now, I want to go back a little bit to the generator story. Streams probably is the biggest problem in Node. Okay, let me show you this first again. If you look at all these operations, like the write, the read, the shutdown, everything is abstracted as a single operation that starts and then ends with a callback. It runs for a while and then like produces one single result, or maybe an error, you don't know. If you think about it this way, it becomes really easy also to support stuff like generators and promises in Node. Because a promise basically is nothing more than a placeholder for some result in the future. However, nowadays in Node.js, it's quite hard to support promises. And that's because we have all these weird APIs that do two things. For example, they return two values. This isn't like a little bit of the internals of Node.js. And somewhere there's the line that says des.write data. It's an asynchronous function call. Normally, it can take a callback. We are not using the callback now, but it can take a callback. And it produces, in principle, no value, except that it might produce a value where it says it failed. But it also returns another value immediately. All these like weird little things that we have done in the past in Node.js make it really hard to support generators. Also, for example, event emitters, like waiting for a data event, you cannot abstract that as something that you start now and produce a result in the future. Instead, how we have abstracted things in the past is like to push stuff in your face. I think this is not the right way to do things. Unfortunately, or maybe fortunately, Node.js is not on its own. Like it has also become a very important part of the web. I think it's treated as being part of the web, even if it doesn't share many of the standards bodies. It has a separate development timeline. And what's going on the web is something very different. This is a streams proposal made by the WG. I don't know what that means actually, but they came up with a lot of the HTML5 standards initially. And when I read this, I'm like, what's going on here? I think it is widely misunderstood, mostly because the people that write these standards do not understand, or they do not have this notion of a very simple abstraction underneath. It's something, I know the guy who wrote this, by the way. His name is Dominic Denicola. I mean, we are good. We debate this a lot. I would hope that in Node.js, actually, we would not have to adopt this. I think we will adopt it if this actually becomes a standard. But what I would like much better is we could just do this. Like if you grew up as a C programmer, or maybe even PHP programmer or something, then this would be very familiar for you. The only thing I did here is insert two yield statements, and now suddenly it becomes very simple again. You read something here, you write something there, and now you're pumping data from one stream to another. Very simple. Unlike this, for example, it's not even readable. Well, whatever. So that's part one. Like this is my vision on how we can manage async better. If you have good ideas here, well, I would welcome you to try it. Like the zones idea, for example, is something that is just an experiment at this point. Nginx, or how to become a better web server. Of course, this is old news, right? This is, no robot drone armies. We've been trying this for 4 years. I think what you have to understand is that in the past we were limited by the limitations of Node.js and JavaScript and the V8 runtime, and also the choices we made ourselves. So for example, when we wrote libuv, we were very pragmatic. It's a C library that basically does whatever Node.js 0.4 did. So Node.js 0.4, like for your context, is like around 2012. No, 2009, sorry. What we added in Node 0.10, or in Node 0.6, and what still exists in Node 0.10, It's a so-called Pre4th Model. The idea is, and it's very old, is that you can create a process, and a process creates a server, a socket that can accept incoming connections, and now you fork the process. You split it up in like 5 or something, or the number of cores you have in your CPU, and then they all start to try and accept incoming connections on that server socket. This is a very old model. This is how Apache used to work. I think it was invented in the 80s or something. We thought this would be like the best thing ever, dump the responsibility for load balancing and for making a fast web server on the operating system. Unfortunately, it turns out that it is not fast at all. We don't exactly know why, but it seems that especially Linux is trying to sort of fight with us because they don't want us to do it. And what happens is the Linux scheduler decides, well, if multiple people are competing for accepting connections on one server, then we'll just favor one and give the other ones nothing. That was really unfortunate. So what we did in Node.js was we moved to a model where you have one process and it is a dispatcher. So how it works now is you have a master process that accepts all connections and immediately tries to dispatch them to different worker processes. That's, of course, a better model. And the only unfortunate side effect is that now there are all these bottlenecks, like accepting a connection and then handing it off to another process is actually not very fast. It is faster, and it's especially more fair because we have more control than the old model, but it's not fast. So very unfortunate, but Node will probably have to move to a model where it is multi-threaded. Like it's a bit un-Unixy, many people feel. But it gives us all these new opportunities for making faster web servers. Another thing would be that right now, because Node.js is a single-threaded thing, every heavy computation that's involved with being a web server, for example, decrypting TLS or SSL, or un-gzipping even, or even HTTP parsing, if you want to offload that to different threads, we have to do a lot of synchronization. We have to read incoming data on the main thread and then dispatch it, and then after, for example, decrypting it, we have to synchronize with the main thread and then dispatch something else. And because the main thread may be busy, it may be running your JS code, that may take a while, which makes it very hard to beat Nginx, which is optimized for making very fast pipelines. Now, so this is something that we would like to do. One of the downsides, though, is that, as I said, libuv doesn't support this yet. libuv is nice, but it has too many. It's too closely mapped after Node 0.4. This is unfortunate because I think libuv is actually very successful. It's being used, for example, now by new programming languages like Julia and Rust. There's a ton of bindings for it, for example, to Lua, and people have experimented with creating very low-level bindings to it, to JavaScript engines. The unfortunate situation, though, is that because it's so nodey, other languages have to sort of reverse this. For example, Rust has a very different thread model, but it has to, as soon as you start doing I/O, it has to behave like Node.js very much. It has to pin like conceptual threads to actual threads. Otherwise, libuv cannot deal with it. This is something that we have to work on, and this is something that is coming. Actually, libuv 1.0, it has its own release timeline nowadays, decoupled from Node, is about to be dropped, and that is because we actually want to start working on libuv 2. This was actually a short part. Let's go to Java or Unix or be a better platform. The reason I want to talk about this is because I have a mentor that is a Java guy. And so immediately when we founded our company, what we started working on is giving you all the instrumentation that Java people are so used to. And this is all stuff. It tells you like latency in the event loop. This is just something, this is a screenshot of one of our products. I won't go explain what these graphs mean. But I think more importantly, what Java had to offer to the world is the concept of write once, run anywhere. Node.js, of course, can offer this as well, as long as you stick to JavaScript. But JavaScript is a nice language, but it is not the best language in the world. Sometimes people come to me and they will ask me, for example, hey, I have this problem. I want to resize an image in Node.js. How do I do this? And the only answer we so far have is like, well, that's kind of heavy. And if you did it in JavaScript, it would be really slow. Why don't you just spawn ImageMagick under the hood? I have heard people say that ImageMagick is like a cockroach. It will never die, but at least let's give it a spin, right? Can we make it a little bit more efficient than that? So the challenge for us is like, can we make Node a little bit more polyglot, if you will? And can we make that a better platform than Java? Can we make that write once, run anywhere? By the way, so this is a little side path. But writing compiled add-ons right now in Node is like it's not fun. We use the build system called Jib. It's written by Google for Google Chrome. And so every compiled add-on nowadays uses that. And then someday, someone woke up at Google and decided, no, we don't like this anymore. We want to replace this script, which looks like JSON, but is not quite JSON, by something that looks like an imperative programming language, but is actually not an imperative programming language, because it's like totally static. That's so weird. So this is the move we might have to make, go from Jib to GM. I believe it was some Canadian prime minister who once said, well, if you sleep next to an elephant, you're going to feel its every move, however benevolent it might be or something. And this is really true for us. Like we like Google in a way. They write V8. They write all these great tools. They have the best engineers maybe. But they do these things, and we have to deal with it. Other things, V8 changed its API. Now, we have something to deal with that nowadays. It's called MAAM, and it abstracts away the differences between like the old and the new V8 version. So if you want to write a compiled add-on that works on all Node versions, there's a stopgap solution. But I think in the long run, this is not acceptable. We have to go further, and we have to take control of this ourselves. Which means that, like, from the build system, we need to define the API for the build system. We have to have a stable API and a stable binary interface for everything that compiles to it. But even then, we are not done, right? Because you might be able to write a compiled add-on, but then you have to compile it. And then the question becomes, well, if it runs with GCC, will it compile with Clang? Will it run on Windows with Visual Studio? So there are multiple things we can do here, and at least what we can do is look at what the web does. Now, on the web there are two paths, and the first one is it's awesome.js, and I think I'm gonna create a lot of haters here, but I really dislike awesome.js. I actually looked at some compiled code. I pre-printed it because otherwise it would maybe like it would go that way. I didn't want that, and this is unreadable. Like this is even worse than assembler. Most people, I think, like can understand assembler a little bit, but here you cannot even identify the operations that's going on. I mean, I can tell you that actually, like if you do, like if there's like a star somewhere or like a bit shift, that actually is an actual operation, but like somewhere there at the bottom, a value is ORed with 0. It means nothing. It's just a hint for the compiler that it's not violating awesome.js rules. It means nothing. Nobody can read this stuff. So, and the other thing is, of course, V8 doesn't support it. The other thing is what we can do is look at what Google does. And this actually has a lot less fans, but I am a fan. What Google did is they said, well, C++ is really a compiled language. And so can we find a way to run compiled stuff in the browser in a safe way? And they found two ways, basically. They started with saying, well, let's compile to just x86 assembler code and try to run that in the browser. And that, of course, is unsafe. You could compile to code that just deletes all your files, whatever. So they run it in a sandbox, but they thought that was not enough. They really wanted to have control, so they defined little rules that your compiled code your compiled assembly code had to adhere to, so they could statically check that it would not do anything malicious. I can explain all the details, but the tricks they use there are really weird. But the funny thing though is that it works. I found this an interesting idea, but maybe a little bit too weird. But then actually, some very bright guy said, well, there's this other project called LLVM, and it's a compiler for almost everything. It's really, really well structured. And when LLVM compiles stuff, somewhere in the middle it creates bitcode, maybe a little bit comparable with Java bytecode, if you will. Now LLVM bitcode is not completely architecture and platform independent. It's certainly not platform independent because it has no relation, but it's not architecture independent. But what they could do is define a subset and change the compiler a little bit to produce only things that are platform independent. And so what they did is they said, well, why don't we just package this bitcode, then ship it to a browser, then the browser runs this last final step where it compiles bitcode into actual assembler code that can run, and then just execute that. I think this is a really interesting idea. So that's the part, the Pinnacle translator that does this. I'm thinking, why can't we just put this in Node? Why can't we just say, well, all your compiled add-ons get compiled with Clang, and then Node ships with this last final piece of the compiler, and so it can be architecture independent, and you can just compile your compiled add-on anywhere and just run it everywhere. We have Java, but with an AOT compiler, basically. Now, of course, there's another problem here, because being architecture independent does not make you platform independent. What Linux may be able to do is completely different from what macOS can do. Well, not completely, but certainly completely different from what Windows can do. And so libuv might actually be our answer here as well. What libuv can do nowadays is almost like an operating system. Maybe it has no support for GUIs, but it supports sockets and files and all those things, and actually quite a little bit better than most operating systems, because most operating systems really suck at asynchronous I/O. If we can expand this a little bit, we might be able to offer people a platform where we say, well, link with libuv, compile with Clang or with Pinnacle, and then you can run it anywhere. I think this is an interesting idea, but who am I? So other people are looking into it as well, and they are skeptical, as they should be. libuv, of course, still has to get a little bit better, and that's mostly because it has to be a little bit more Unix-like. I'll show you this. This is one of the mistakes we made. In Unix, you have this idea that every file descriptor, whatever, or everything is a file descriptor. A socket, a file, a mutex even if you want. Doesn't matter, it's all a file descriptor. libuv, we didn't copy this model. That's really stupid. We said, well, let's make types for everything. And so, to create a TCP thing, you call uvtcp in it, and you create a thing that has type TCP. And so this worked really well, because this was basically everything. This was basically all that Node.js 0.4 supported. However, in the future, and that's, I think, also really related to the IoT people that might be here, we, of course, need to support many more types of devices. There's already people that control flying drones with Node.js, and they now have to use a compiled add-on because libuv doesn't support this. And we don't want to support this because we cannot extend this list forever. Or what if you want to run it on a mobile device? Right now, I think you can run Node.js on Android, but I don't think it has APIs to access the camera, for example. And we have to add these things. Otherwise, we cannot call ourselves a useful operating system or platform. Some other stuff. I actually didn't announce other stuff, but there's two more things that I want to say. One thing that I find always really problematic when I start writing Node.js code is to write scalable code. I think we all understand how to do it, like write stateless web servers, for example. Use message queues if you want to write scalable systems. But as we all understand, every cloud starts on your own machine. And it's like so painful when I have to start my development by installing RabbitMQ and Redis and some database and some other stuff, and then run it in a Docker container on my machine. I mean, like by the time you're done with that, you just, it's time for beer, Your project never starts. This is something I think we should try to fix in Node.js. Node.js would be really nice if it were a good platform. But it's also nice if it's a great tool just for local development. One thing I think we could do here is ship it with not a great message queue, but with okay message queue that only runs on your local device. And then, for example, when you deploy, allow you to switch it out. Basically, it's dependency injection revisited, but for a different purpose. I think when people came up with dependency injection, they imagined that someday your manager would wake up and he would decide to switch over to another payment processor or something. This is stuff that never really happens. But what does happen is that you run locally and you decide, I want to deploy, and when I deploy, I will use an actual message queue. It's also where the role of cloud deployment is moving, right? If you go to Amazon, you have SQS. It's a message queue, but you cannot install SQS on your local box. And I think the other thing that's really important now is to support mobile devices. Most of the people that work on Node.js, of course, they use Windows, like me, or they use Linux or Mac. And developing on a mobile device right now is not possible. But of course, mobile devices they're ubiquitous. And if you want to write something that runs anywhere, we have to be much more serious about this. Right now, that's not really possible. If you cannot run Node.js on an iOS device. And the reason is very simple, because Apple doesn't let us run V8 on an iOS device. So we can just ignore them for a while. There are, however, ways out. We know we can run JavaScript on an iOS device, it's just not V8. So the question that we have to ask ourselves is, do we want to be bound to V8 forever? Or do we want to be more, I would say, open-minded? Do we want to say, well, Node.js is a set of APIs and it's a platform, but it does not define which JavaScript engine you use. It is my favor. Right now, there's nobody really that cares enough to actually make it happen. But for example, if you have some spare time, you're very welcome to do that. So to conclude things, I think it's almost time also. Node.js, as I said, is a community project. So these are my ideas, and I have some influence here, but I do not pull the strings. We created this GitHub repo. It's called Node Forward, and it is where the community, and right now it's kind of an in-crowded community, but it's open. Has discussions about different things, about technical situation, also about release timeline, about how we want to version things, and about how we do governance. If you are interested in looking it up or learning to know more, I would highly recommend to look here. Thank you very much. I'm not sure if you have any time. Otherwise, I can answer some questions for you. Oh, that's 4 minutes. I'm seeing one hand there.
Zones you mentioned, does it have something to do with Brian's Zones project?
The question is something with, yeah, there's another Zones project by Brian, but I forgot his last name. Ford, yes, exactly. And his focus is a little bit different. He's trying to do things for Angular, and it's mostly related to detecting when they have to refresh. Because in Angular, you can change things, and then they have to, at some point, update the DOM. But I've spoken to him a couple times, and actually, I think we are slowly converging. We are certainly converging in terms of ideas, but our projects are not so far. But we don't know yet. Are there any other questions? Okay, one more.
Can you explain the version numbering system that happens with Node?
In Node.js, yeah, versioning number, it's really simple. It has an even odd number version. So 02, 04, 06, 08, 010, 012 are stable, and 011, the odd versions are, they change all the time. You just want to run them to try them out. I think nowadays, by the way, if you pick a very recent 0.11 version, it's basically what you get if you install 0.12. And I think we will switch to send there after we go to 1.0, which hopefully will be soon. Okay, one.
Do you know what happens to Express now? Do we have to switch to that?
The question is, do I know what happens to Express? Yes, I know what happens to Express. Actually, like it's maintained by my coworkers and some people from the community, and there will be a lot of exciting stuff coming. And I think one of the things that will happen really soon is Express will also start to adopt generators like Koa does. So if you're interested in that, you can actually stick to Express.
Can you talk about the Node.js dispatcher model, if it's faster in terms of performance with the Pre4th model?
So the question is, can I explain whether the Node 0.12 dispatcher model is faster? Yes, in our benchmarks, it's consistently faster. That is mostly related to the fact that it distributes connections more evenly. So what I don't know, because you cannot measure this, is whether the process that gets the most connections is more performant than an average process in the dispatcher model or something. I don't know, but like the entire cluster, if you use it, is faster. The question is, does it matter which operating system you run on? Well, we only support it on Unix. We don't do it on Windows, but you probably didn't care about that. For Linux versions, as far as we know, it is faster on every Linux version. The only thing I have to add here is that sometimes we could do like little tricks or tweaks. For example, inserting like a little busy wait, which we would have to tweak very specifically for a particular, like basically computer, like with an operating system on it. We could get the Pre4th model to be faster. But of course, we don't want to put the burden on you, like go tweak this like magic variable to be slightly faster than dispatch model. So we just switch over to the dispatch model entirely. I probably cannot hear you, so maybe if you want to come up here or shout. The question is, how do I feel about TJ leaving Node.js for Go? Well, I'm totally cool with that. You have to understand, when Node.js was really new, it attracts people that like shiny new things in a way. And also, it attracted, at the time, systems programming people very much, like myself. I think in 2010, there would be people that would tell you, like with a serious look in their eyes, I use Node.js whenever I have to, go do something low level. I think nowadays this is not how people approach it. Like Node.js is a high-level programming language, and you would use Go, for example, if you do something low level. And so what you see is that people like Felix Geisendorfer and TJ Holloway-Chuck, they will decide, well, I like this low-level stuff better, so I will play with it. And sometimes people come back. Like I think Ryan Dahl, for example, he played with Go for a long time. He may still be using it, but I think his like, initial love for it, went away a little bit. Okay, my time is up. Thank you very much.